Hey, hey, you! Yes, you! So you want to be a developer for Retroachievements, do you? Hello there, dear viewer. It is I, Masquerade, from Discord, and I'm here today to explain how this series will work. This is the Retroachievements Handy Dandy Employee Handbook, and it will cover the basics of how to do achievements, starting from simple stuff and then going into more advanced stuff later on. This series will be edited as well, so you can have the best experience while learning. Thank you so much for watching, and let's get right into it. This video will cover the basics on how to find addresses, along with the means of finding them, that being the filters you can use to find memory in the game you wish to do. Like, for example, equals, and equals, last value, constant, and a few more. Now, with the scripted stuff out of the way, let's get right into it. So, to start off with, we're gonna be using Rollup Retro for this tutorial. Now, you can use a few other emulators, mostly console-specific ones, but there's also BizHawk and a few others, I think? Not sure. Anyways, first thing you're gonna do is you're gonna go into Retroachievements, then log into your account, which is your site account, meaning it's the same username and the same password as you have on the site. After you're done, you're gonna go into Settings, Manage Course, click here, and then search out the course for the system that you want to develop. In this case, we're gonna be using the Game Boy, because we're gonna be using Kirby's Dream Land as this tutorial, sorry. So, after you click the system you want, you're gonna see this screen open up, yeah, that works. With all the downloads here, these are the cores for the system you put in here. And you can use any of them, any that you like, all of them work. But I will be using MGBA for this tutorial, which shouldn't change anything, to be honest, aside from graphics and audio. So after you downloaded your core, you're gonna go to File, select Core, the system you want to dev, and then the core. Now it's loaded, as you can see here. You're gonna go to File, and then Load Game. As you click Load Game, a new window will pop up, and you will have to go through your PC's folders to find the ROM you want to use. Obviously, you have to legally acquire these ROMs through the cartridge and then dump them into your PC. But, as I've already loaded the game, we can just load recent right here. Here it is. It's Kirby's Dream Land for the Game Boy. So, what we're gonna try to find is the health address. The address that determines how much health you have. So, we're gonna go into for us to start finding addresses, we're gonna go into Retroachievements, and then we're gonna go into Memory Inspector. Now, immediately, there's a lot of information. You can mostly ignore this section for now. But, as you can see, the blue numbers represent addresses that already have code notes, which, because this game has already been rammed before, it will have a lot of code notes, but we can ignore them for this tutorial. So, let's start the game, of course, so nice. Let the cutscene play out, and then we're here. The game is here. What we're gonna do is we're gonna click New Search to start a new search in the addresses. The addresses of the entire game. Now, here's the number of total addresses in the game. Now, as you can obviously see, going through all of them would be horrible. It would be long, it would be inefficient, and that's not what we ask of. So what we're gonna do is we're gonna filter the addresses to narrow them down. As you can see, we have not changed the health address at all. It's remained the same, basically. Yeah, it remained the same. So we are gonna go here into the two drop downs, which some of you may have already seen. Now, what the drop downs do is that they're what the current frame will be filtered against. So this is the accessor, and this is what it will be pinned up against. For now, we're just gonna use this one. We will explain this one at a later date. But for now, we're gonna use equal and ain't equal. You can see this one has an exclamation point. Exclamation points in Retroachievements and coding generally mean not, meaning not equals. So firstly, we're gonna do equals because the health address has not changed. So it is equal the new search. So we're gonna do a filter once to narrow the addresses down one time. Now, we have already a starting point. So now we're gonna change to not equals, and then we're gonna get hit before filter. We got hit. Now, since our health value decreased, we can use not equals last value. We have already narrowed the addresses down quite a bit. Let's get hit again. Now that we got hit again, we will filter again. We have already narrowed the addresses down a lot. Let's do it once again. And another time. And once more for good measure. Now, we have already filtered addresses quite a bit, but we can still filter out more. Well, how we do that is we go here, equals, and then we're gonna pause, let the bird fly by. Goodbye, friend. Anyway, we're gonna go here, and since the health address isn't changing at all right now, we can do a continuous filter. Now, what a continuous filter does is that every frame possible, it will filter out addresses by the two drop-downs. So, in this case, every frame, the address will be has to be equal last value. So let's continuous filter, and now let's move around a bit. Do a lot of things just to narrow down the addresses. It already appeared there, but we can ignore it for a little bit. As long as you don't get hit, you can continue filter. Very nice. Once you want to stop, all you have to do is click here. Now we have narrowed addresses down quite a bit. So, it already appeared, but if you didn't know that this address was the one we wanted, all you had to do is pin these addresses against this one, against the thing you want. So in this case, it would be a single health point, meaning addresses that are 0, 1 would be ideal for us. So, but let's go here in this one. Now, you would do this in every single address that is system RAM, because things like background to data and echo RAM, they aren't usable for achievements. They cannot be used, and they are very inconsistent. So what we're gonna do is we're gonna go here. Very nice. We found the address. But if you wanted to test it, to truly have a feeling that it is the correct address, we can go here. The red numbers are the ones that the address is, which is this one. Basically here and here. So, if we want to test this address out, all we have to do is get our keyboard and press a key. It has changed the address's amount, and it has changed our health value. So we know this is the correct address. Now we can do whatever with it. We can change it to 4, we can change it to 3, we can change it to 7. Not sure why you would do that, but you can. And we have found our first address. Now, on to the next section. So, you have learned the basics of how to find addresses. Now, what we're gonna do is we're gonna learn a bit more advanced stuff. Something that is more precise than before. For this tutorial, for this section of the video, we will be using Dr. Mario. Here's the game, all fine and dandy. And what we're gonna try to find is we're going to try and find the amount of viruses remaining. So we will open the memory inspector. All nice. There we go. Now we're going to do a game, of course. So one tip you can do is you can press P to pause the game with the emulator. The emulator will pause, but you can still search out addresses, meaning you can do stuff and have a time to breathe so the game doesn't keep going. Now let's do a new search, and instead of doing equals and then equals, we are gonna do greater than and less than. Well, less than and greater than. This is the less than, this is the greater than. And there are a few ways you can remember which is which, but that's not what I'm here to teach. Sorry. Now, what we're gonna be using is lesser than, because we want the current frame to be less than the last value. So, let's lower the virus amount. We have lowered the virus amount by 1. Now let's pause again, filter once. Now let's unpause and keep doing it. We have lowered it again. Okay, nice combo. Now, again. We already have a bunch of addresses. Mirror RAM is the same thing as Echo RAM. It cannot be used. Let's ignore that for now, shall we? Let's continue. We have lowered it again, so let's do it again. And we already only have 8 values, 2 of which are usable. So, for us to test it out, let's unpause the game and then 0. We have beaten the level, meaning this is the virus address amount, remaining viruses. We have found our second address. So, you have learned how to walk, and you have learned how to run. You have learned the basics of RAM digging, and you have learned more advanced stuff. But now, it's time for us to fly. Because there is one last way to find addresses that is extremely, and by that I mean extremely precise. But it requires you to predict what the address currently is. Like the value, what it currently is. So for this tutorial, for this section of the video, we're going to be using Lego Batman 2 DC Superheroes, which, yes, is my own set. So I'm kind of playing my own violin here, but I don't think that matters much. Anyways, we're going to skip these credits. We're gonna continue. And we're going to walk into a level. Here. Okay, so we are in the level. Now, what we're going to try and find is the stud amount. What it currently is right here. The number that is currently right here. So what we're going to do is we're going to do a new search, and instead of going into this drop down, we're gonna go into this one. Oh yeah, we're talking about constant. Now, as you can see, there are others in here. Initial value, it is basically the value that is when you click new search. That is the initial value. Last value plus and last value minus is last value plus the number you input into it, or minus, depends on which one you choose. So basically, last value plus and the number you input into it. But we will discuss this in much greater detail at a later date. For now, we're going to be using constant. By the way, quick little tip you can do. You can actually scroll through these with the mouse wheel. Both drop downs you can do it. So that saves a bit of time. But anyways, some of you may have already noticed that a box opened up right here, and you can type in it. Basically, this box, what you input here is what the constant means. So basically, this frame's value equals 1. So you can already see how that is very good. Very, very, very good. Now, first thing I gotta mention is that if you are using it, it will instantly default to decimal. Meaning if you put in 10, it will give you results that are like this. So if you want to do like this one address, for example, instead of doing 23, because that would give you the wrong address, we do 0, X, and then 23. So that's how you convert it to not decimal. So let's put in here 100, which is the current stud amount we have. We have a lot of addresses. And let's get more studs. And then input it right in here. Oh yeah, one thing I wanted to mention. If you, for some reason, a lot of achievement making is trial and error. So if you, for example, put in the wrong number, or if you put the number and it wasn't correct, you can just click this little button here to go back one step on the memory. The address is shown in here. And you can click this one to go forward. So yeah, that's very good for if you mess up or if the address wasn't what you thought it was. So let's put it here. And we already have it. Yep. It was that quick. Now, of course, the amount of things you have to do to find the address is obviously going to depend heavily on the game and the addresses that the game has and a lot of things. But this is basically how you one of the most efficient ways of finding addresses. Now you can go get more and more, and as you may have noticed, let me pause you. It went over this one. This is what we call an address that isn't 8-bit. an 8-bit address is only these, but they only hold up to 255. That is the max that they can hold. But over here, we can choose it to be 16-bit or 32-bit, which make it more, which make it so that it's a bigger value that can be stored in the variable. So basically, you can go here and then choose how many beats you search. So basically, if we do, hold on, let me just, yeah, that guy was annoying. Okay, so if we go here, new search, and we search for 8-bit, and we search for the free 10, that isn't going to work. That is going to give us 0 addresses, because that is more than what 8-bit can hold. So what we gotta do is we gotta go into 16 or 32-bit. So you click new search with the 32-bit, and then you click filter once. Now, as you can see, it worked. So that's how you search for values that are bigger than 255. And you can see in the memory here how it works. And if you want to test it, of course, you can go, and it's a 32-bit value. Thank you so much for watching, and have a good one.